Hello, everyone. In this video, we are going to continue example 1 from section 4.2 and section 4.3. We're going to look at part B. So before continuing with this video, I encourage you to attempt this example on your own first. This is going to be very similar to the part A of this example, but now rather than just using 2 rectangles, we're using 4 rectangles to compute our estimate. When you're ready, let's continue together. So let's start with the left-hand sum again. All right, so for the left-hand sum, we're going to be using 4 rectangles. So I'm going to go ahead and just draw in those widths. 4 rectangles from 0 to 2. That means I'm going to have my endpoints at 0, 1/2, 1, 1.5, and 2. So now using the left endpoint, I'm going to draw in the heights of my rectangles. So the first one has a height here. Next one, we're over here. Next one down here. And our final rectangle starts on this left-hand side there. So what is the values or the areas of these rectangles? Well, the area of a rectangle is height times width. My widths here are all going to be 1/2. And we see that because we have 1 to 2, so that's 2, divided into 4 rectangles, gives me 1/2 each for a width. All right, so 1/2 is my width, and we can compute the heights by using that function value on the left-hand side. So let's compute what those heights are. So first we have f of 0 times 1/2 plus f of 1/2 times 0. And again, I'm using the function output at the left-hand endpoint. So my next height will occur at the function output at x equals 1. So my next height would be f of 1 times 1/2 plus f of 1.5 times 1/2. Oops, and good catch. I don't know where that 0 snuck in here. We're multiplying by 1/2 because that is our width of our rectangles. All right, so let's compute what this number should be. So f of 0 gives me e to the 0 times 1/2. Then I have plus e to the negative 1/4 times 1/2. And actually what I'm going to do is just factor out a 1/2 from each term before writing this out. So notice each term here in my sum has a factor of 1/2. So I'm just going to bring that out front and then write out all of my heights. So f of 0, we can continue, is e to the 0 plus e to the negative 1/2 squared plus e to the negative 1 squared plus e to the negative 1.5 squared. All right, so now let's go over to our calculator to compute this value as a decimal. And we get, feel free to pause so you can check yourself first. We should be getting something near 1.126 is the area of the left hand rectangles. Awesome, beautiful job. And we can just fill in that area so we can see what we've just computed. Awesome. Now, if you haven't done the right hand intervals yet, or the right sum rectangles, go ahead and pause the video and fill that out, and then we'll compare our work. All right, let's go for it when you're ready. So now we're taking a look still at 4 rectangles. So I'm just going to start sketching those in. But now we're using the right hand endpoints to compute the heights. So I'm going to go towards the right, look at that right endpoint, and draw in my height there. So here's our first rectangle, right endpoint up here, right endpoint over here, right endpoint over here. All right, so now we're computing the value of this area. So similar to the previous problem, we're going to set up our sum, right sum using 4 rectangles now. And I hope someone caught me here too. This should be a 4 also because we're looking at 4 rectangles. Nice job. All right, so let's compute these areas. So now we have height is going to occur at the right-hand endpoint. So will occur at f of 1/2. Width is 1/2 plus f of 1, width is 1/2. We see that we just move over to 1, height, f of 1, plus f of 1.5 times 1/2 plus f of 2 times 1/2. So similar to the previous problem, we can factor out a 1/2 and then just compute those heights. So we get e to the negative 1/2 squared plus e to the negative 1 squared plus, let me continue down here, e to the negative 1.5 squared plus e to the negative 2 squared. Whew, nice job. One other thing we want to, little slip here, this third rectangle is evaluated at f of 1.5. So we just need to include that extra 1. That's why it's so important to take our time, slow down with these, work on the problem multiple times, because it's easy to drop a little number here or there. All right, so now let's go over to our calculator and estimate this decimal value. We get 0.635, and that's going to be the area of the right sum rectangles. So now to end, let's just consider how the actual area under the curve compares. So we see, just looking at this picture, that the area under the curve is going to be smaller than our left-hand sum, but larger than our right-hand sum. So we can say the area under the curve is between 0.635 to 1.126. And before we leave, let's just compare this interval that we just found, or this range, 0.635, 1.12, to the range we found in the first part of this example, 0.386 to 1.386. Notice that this range got a lot smaller in part B. So one takeaway that we can see here is that using more rectangles gets us a better estimate for the area. So if we were to do this again, and I'd encourage you to do so, using say 6, 10, 20 rectangles, you're going to get a better and better estimate as you go along. All right, thanks for your hard work.